Hello dear student, I am a chemistry teacher Vikas Kumar. Today I am going to teach Unit 1, some basic concept of chemistry. In this chapter, we will discuss about previous year question of NEET. So watch my video carefully, okay? Now question number 1 is the dimension of pressure are the same as that of 4 options are given. Now this question is based on calculation of unit and dimension. So initially name unit and dimensions. Now name is mass, length and time. SI unit is kg, meter, second, and dimension is ml/t. So with the help of this table, we can solve this question easily. Okay, so dimension of pressure. Formula of pressure is force per unit area. F is equal to ma, mass into acceleration. Area is L square. Now unit is kg, meter per second square, and length is meter square. So kg per meter per second square after applying dimension m L inverse T inverse square in terms of dimension. This is dimension of pressure. So one by one we can check here. Now for option 1 A, force per unit volume F by A. Here force is kg meter per second square, kg meter per second square, and area is force per unit volume in terms of force per unit volume. Now in option A, force per unit volume is present. So force by volume. So force is kg meter per second square, and now volume is meter cube. Now kg per meter square per second square. Now in terms of dimension, we can write m L inverse square and T inverse square in terms of dimension. Now m L inverse square, T inverse square, T inverse square. So option A in dimension, in case of dimension of option A and dimension of pressure not match, so option is incorrect. After that we will discuss about option B, and according to option B is energy per unit volume, energy by volume. So what is unit of energy? Energy means kinetic energy half mv square. So mv square means kg meter per second whole square. So finally kg meter square per second square. Now in terms of dimension, m L square T inverse square. This is dimension of energy. So m L square T inverse square by, in case of volume L cube. Now after calculation, m L inverse T inverse square in terms of dimension. So we can match option B, dimension of option B, energy per unit volume, with pressure m L inverse T to the power minus 2 T inverse square minus 2 power. So option B match, option B is correct. Now we can check in dimension of force. Here dimension of force is, you can check here, kg, unit is kg meter. Okay, kg meter. Here force is F is equal to ma, kg meter per second square, kg meter per second square, and dimension is ml/t universe square. Okay, so this is dimension of force. In case of energy, dimension is here m L square T inverse square in term of dimension. So finally all dimensions are find Now one by one you can match. So dimension of pressure M L square L M L inverse T inverse square match with option B. So option B is correct. Now question is solved. You can take a screenshot. Now I am going to solve question number 2. According to question number 2, what is the weight of oxygen? What is the weight of oxygen required for the complete combustion of 2.8 kg of ethylene? Options are given. According to this question, what is required weight of oxygen for combustion of 2.8 kg of ethylene? Now I am going to solve this question. Now C2H4 is molecular formula of ethylene. Ethylene. Combustion in presence of oxygen or with oxygen. So combustion reaction occurs here. Now after combustion, CO2 and water is obtained. Now for balancing of this equation, we can use heat and trial method, and now due to balancing of 4 hydrogen, we can use here 2. Now oxygen 2 to the 4 plus 2 6. So now we can write here 3. So carbon is 2 in LHS. In RHS also 2. Hydrogen is 4 in LHS. 2 to the 4 in RHS hydrogen present. Oxygen is 3 to the 6 oxygen in LHS. In RHS 2 to the 4 plus 2 6. So this combustion reaction is completely balanced. Now according to question, actually molecular weight of this molecule C2H4. Now carbon is 12 to the 24 and 4 1 ja 4. So molecular weight is 28 gram. Now 28 gram react with atomic weight of oxygen 16, and due to presence of 6 oxygen, 96 gram is total molecular weight of 3 molecules of O2. So 96 gram. Now according to question, since 28 gram of C2H4 react with 96 gram of O2 in combustion reaction. Now for combustion of 2.8 kg of ethylene, or 2.8 kg of C2H4, the amount of oxygen is required. How much? 96 gram divided by 28 gram and divided by 28 gram and multiplied by 2.8 kg, or 2.8 into 10 to the power 3 gram. Okay. Now 10 is divided by 2.8. A decimal is replaced from this place, and 28 cancel by 28 and 10 cancel by 10. 10 to the power 3. Now 10 to the power 2 is left here. Now 96 multiplied by 10 into 10 gram. Now 9600 gram is here. And now in terms of kg, whenever divided by 1000, then 0 cancel by 0, 0 again cancel by 0, 96 by 10 kg means 9.6 kg, and according to given option C is 9.6 kg. So option C is correct. You can take a screenshot. Now question is complete. Now I am going to solve question number 3. According to question number 3, boron has 2 stable isotopes, atomic number 10 19% and boron atomic number 11 81%. Calculate average atomic weight of boron in the periodic table. Options are given. According to this question is completely based on calculation of average atomic weight. Now according to given data, 2 isotopes are given here. Boron, one isotope 19%, and another isotope 81%. In case of 91%, their atomic weight is 10. In case of another boron, atomic weight 11, their percentage 81%. Now, according to given data, the formula of average atomic mass. Average atomic mass of isotopes. Now, percentage of element and multiplied by atomic weight plus percentage of element multiplied by atomic weight and divided by total percentage, means 100. Now, according to given data, percentage of boron 10 multiplied by atomic weight of boron 10 plus percentage of boron 11 into atomic weight of boron 11 divided by 100. Now, percentage of boron is how much? 19% multiplied by atomic weight 10 plus percentage of boron is 81% and multiplied by atomic weight 11 divided by 100. Now, 190 plus 81 multiplied by 11. Here 81. Now 891 divided by 100. Now, after summation of these digits 1081 divided by 100 and 1081 multiplied by 10 to the power minus 2. Now, decimal is here, and after, due to removal of this point, this 10 to the power minus 2, 10.81. Okay, 10.81. This is the average atomic mass of boron. So, according to given options, option A 10.8, here 10.8. So, option A is correct. You can take a screenshot. Now, question is completely solved. Now, question number 4 is completely based on calculation of average atomic mass. Question number 4 is, an element X has the following isotopic composition. X atomic mass 200 and percentage 90%. X atomic mass 199, percentage 8.0, and X atomic mass 202 and percentage 2.0. Now, the weighted average atomic mass of the naturally occurring element X is closest to. Options are given. According to this question, these three isotopes are given, their atomic weight are given, their natural occurring percentage are given. Now, what is average atomic mass of these isotopes, isotopic elements X? Now, with the help of formula of average atomic mass, average atomic mass of element is sigma percentage of element multiplied by atomic weight of element and divided by 100 total percentage, AMU. So, this is master formula. Now, after applying this formula, according to given data, percentage 90%, 90 multiplied by atomic weight 200 plus 8.0 multiplied by 199 plus 2.0% multiplied by 202 and divided by 100 AMU. Okay. Now, after calculation of these sums, we can get 19,998 19,999 and divided by 100 AMU. Now 19,998 multiplied by 10 to the power minus 2. Now decimal is here, and after replacement of decimal from right to left, power become increased. So 199.98 AMU, approx 200 AMU. Now according to given answers, these four options, option D is more correct. So option D is correct. You can take a screenshot. Now I am going to solve question number 5. According to question number 5, what volume of oxygen gas measured at of propane gas measured under the same condition? Options are given. According to this question, whenever propane gas react with oxygen under complete combustion, then what volume of O2 is required? Now, formula of propane is C3H8 and propane react with O2, complete combustion. After complete combustion of propane, CO2 and H2O are prepared. Okay. Now carbon is balanced by 3, hydrogen 4 hydrogen, 4 to that, and oxygen 3 to the 6 plus 4 10. So by 5 to the 10 oxygen is also balanced. Now in these chemical reactions, this reaction is combustion reaction. All are gas in the reactant and product side. Now 1 mole 1 volume. Okay, this is 1 volume of propane. 1 mole of O2, 1 volume, so 5 mole O2, 5 volume of O2, 3 volume of CO2 and 4 volume of H2O. Okay, 4 volume of H2O. Now whenever 1 liter of propane, 1 liter of propane react with 5 liter of O2, then 3 liter of CO2 and 4 liter of H2O are prepared. Now according to question, what volume of oxygen O2? 5 liter volume of O2. So according to given option, option A is correct. Now question is solved. You can take a screenshot. You can like, share, watch my video carefully. Now I am going to solve question number 6. According to question number 6, an organic compound contains 78% by weight carbon and remaining percentage by hydrogen. The right option for the empirical formula of this compound is, options are given. According to this question, what is the empirical formula of compound? If an organic compound contains 78% by carbon and remaining means 100 minus 78% by hydrogen. So what is empirical formula of compound in these 4 options? Now empirical formula represent ratio of atoms and molecular formula represent number of atoms in compound. Finally, empirical formula represent ratio of atoms in compound, and molecular formula represent number of atoms in compound. Now, relation between empirical and molecular. Molecular formula is equal to n into empirical formula, and n is equal to molecular formula mass by empirical formula mass. Okay, now you can take a screenshot. And finally, empirical formula represent ratio of atoms. Now, for calculation of ratio of atoms according to given data, now I am going to solve this question by tabular method. And first, element, and second, percentage given weight of elements. After that, atomic weight of elements. After that, percentage weight divided by atomic weight of element, and last, ratio of atoms. Okay, now I am going to solve this question. According to given data, we can solve this question. Now table is ready. Now first element is carbon, and next is hydrogen. Weight of carbon 78%, and hydrogen is 100 minus 78, so 22%. Atomic weight carbon 6, not 6 here, 12, and hydrogen is 1. Now 78 divided by 12, 6.5 here, and 22 divided by 1 is 22 here. Now ratio, 6.5 is here, 22 is here. Now for calculation of ratio, in these two values, both are divided by minimum value. So 6.5 is minimum in compare with two options, 6.5 divided by 6.5 and 22 divided by 6.5. So 1 is here, and here 3.38 is here. So we can imagine 3. Now according to these sums, now ratio is calculated. Now empirical formula is C1 and H3. So we can write CS3 in given 4 options: CH4, CH, CH2, and D option is CS3. So CS3 is right option. And now question is solved. You can take a screenshot. Now I am going to solve question number 7. According to question number 7, the number of atoms in 4.25 gram of NH3 is approximately, according to this question, in 4.25 gram of ammonia, how much number of atoms are present? Options are given. Now, number of atoms in given mass of molecule, given mass of molecule is equal to given mass of molecule in gram divided by molecular mass of molecule in gram multiplied by Avogadro number multiplied by atomicity of molecule. Okay. Now, number of atoms in given mass 4.25 gram of ammonia molecule is equal to, given mass is 4.25 gram divided by molecular mass NH3, here 14,111, and now 14 plus 1 6, 14 plus 1 15, 16, 17, so 17 gram is molecular mass of ammonia. Now multiply by Avogadro number 6.022 into 10 to the power 23 and multiply by atomicity, total number of atoms present in molecule ammonia 1 2 3 4, so atomicity is 4 here. Now after calculation, atoms, okay, after calculation 0.25 and 0.25 multiplied by 6.022 into 10 to the power 23 into 4, so atoms now 0.25 into 4 into 6.022 into 10 to the power 23 atoms. So after multiplication of 0.25 into 4, 1 into 6.022 into 10 to the power 23 atoms, so 6.022 into 20 to the power 23 atoms. Now according to given options, we can write 6 into 10 to the power 23, and according to these four options, option D is 6 into 10 to the power 23, so option D is correct. Now you can take a screenshot. Question is completely solved. Now I am going to solve question number 8. According to question number 8, the number of oxygen atoms in 4.4 gram of CO2 each. Options are given. In which option is correct? According to question, total number of oxygen atom. How much? Total number of oxygen atom in 4.4 gram of CO2. Okay. Now formula is number of atoms in given mass of molecule is equal to given mass of molecule in gram divided by molecular mass of molecule in gram multiplied by Avogadro number multiplied by number of atoms in molecule, which is required according to requirement. Now according to question, number of oxygen atoms. Now number of oxygen atoms in 4.4 gram of CO2 molecule. Now given mass 4.4 gram divided by molecular mass C plus O plus O. So 12, 16, 16 and molecular mass is 44. Now 44 molecular mass of CO2. Now 6.022 into 10 to the power 23 is Avogadro number. After that, number of atoms in molecule CO2 for the calculation of only number of oxygen atom, 1, 2. So multiplied by 2 atoms of oxygen. Atoms of oxygen. Now decimal is replaced after divide by 10. 44 cancel by 44. Now 10 cancel by 10. Now 2 into 6.022 into 10 to the power 22 O atoms. Okay. Now we can write 2 into 6 into 10 to the power 22 O atoms. Now 12 into 10 to the power 22 O atoms. Now 1.2 into 10 to the power 23 O atoms. So according to given options, option A is 1.2 into 10 to the power 23, 1.2 into 10 to the power 23. So this is correct answer. Now you can take a screenshot. Now I am going to solve question number 9. According to question number 9, the total number of valence electron in 4.2 gram of N3 single minus ion is, according to this question, in 4.2 gram. In 4.2 gram of N3 single minus, how much number of electrons are present according to given options? Now I am going to solve this question. Answer is total number of electrons in N3 single minus ion is given mass. Given mass is 4.2 gram, 4.2 gram, and divided by mass of N3. Now N3 single minus is N plus N plus N. So N single minus, here mass is 14 plus 14 plus 14, 42 gram. Now multiplied by the Avogadro number. Now for calculation of total number of valence electron, total valence electron, two type of nitrogen is present. One is simple nitrogen, one nitrogen with single negative charge. So atomic number 7 and 7 electronic configuration is 1s2, 2s2 and 2p3. So valence electron is 5. Here 1s2, 2s2 and 2p4. So valence electron is 6 here. Now total valence electron is 5 plus 6. 16 total valence electron. 16. Now 10 is divided and decimal is replaced from this place. Now 42 cancel by 42. Now 16 by 10 Na and 1.6 Na is final answer according to given options. Now option A, B, C, D, option C is correct. You can take a screenshot. Now question is solved. Now I am going to solve question number 10. According to this question, the number of gram molecules of oxygen in 6.02 into 10 to the power 24 CO carbon monoxide molecule is. Options are given according to given data. How much number of gram molecules present in given number of molecules? 6.02 into 10 to the power 24 molecules of CO. Okay. According to this question, total number of gram molecules in given molecules, how much can be possible? Now total number of gram molecules in given number of molecules is equal to total given number of molecules divided by 6.022 into 10 to the power 23 or value of 1 mole. Now according to question, given 6.02 into 10 to the power 24 molecules of CO, molecules of carbon monoxide, and divided by value of 1 mole, 6.022 into 10 to the power 23. Now after calculation, 10 molecules of CO is answer, and according to given options, option A is correct. Now question is complete. You can take a screenshot.